Good afternoon once again. I am Engineer Tayo. Today topic will be on how columns is being set and how the axis is being drawn. Firstly, we're going to start from this column. This is the reinforcement, which is the continuous reinforcement. On the continuous reinforcement, we have the receiver from the ground, which is this. So the continuous reinforcement is attached to this. Inside the continuous reinforcement, we have a pipe, which is for collecting water from the rooftop for drain. So on the ground, we have this and this. This is done by the axis. The axis is a point whereby a reference point where you take all your measurements from. So when that is done, these edges of the column is drawn out using a marker. By the time it is drawn, then we have the sleepers, which is the border of the of the column, the border point of the column. This is one of the column, which is the 450 column. So this is one of the cover for it for the form wall. At this place, we have the yellow beam. It is also called the berry. This beam is used as vertical support for the column. That's what we have here. That's what we have here. So it helps to hold the board firmly. After that is done, the board is positioned like this. The board is positioned like this. At this point, we have the 290 mm yellow beam, which is as braces to the board for firmness and stiffness, so that by the time it's been erected and the poker vibrator is put into it, it doesn't open. But here we have the clip. We have this clip. This clip, as you can see here, it is used to hold the
What's the name of this engineer?
That is the clip. We have the tie rod and we have the clips.
Okay.
So the tie rod and the clip is used to hold the columns together, firmly together, so that there will not be burst or opening when it is being cast, when the concrete is poured into it.
What's the spacing allowable between 3 by 3?
The spacement we have at this column, we have 300 spacing. This is 300 millimeter spacing. That's what we have between tie rod to tie rod. The reason is for firmness and to prevent bulkiness when casting. That's why we have.
How to control verticality of columns?
Verticality of columns is being controlled using lines and the plumb.
By acro.
Yeah, by acro.
Is this acro?
Yeah, this is acro. This is what we call the acro.
Okay.
The acro helps, which is the acro props. It helps in the vertical alignment. That is for the column not to move during casting. The column remains firm, stands straight, and it doesn't move after setting. So this is the 300 spacing of the tie rods. That is how we put it. We have them like this, with the 3 by 3 holding it firmly, so it doesn't bulk when
But
casting.
you must brace
Yes, we must
for
brace,
direction
we must brace in 4 direction. And
by
the longer-
acro.
Yeah, by acro. At the longer axis, which is the 450 axis, we have 2 acros. While at the 230 axis, we have single acros at both sides. So
Okay.
in total, we have a total of about 6 acros per columns for verticality.
Okay.
For it to stand well.
Okay, thank you.
Thank
Thank you, engineer.